What's up, viewers? This is your Mathibe. So once again, join me in another lecture video sa subject na reinforced concrete design. Ang topic natin for this video is analysis of doubly reinforced beam wherein mag-yield ang compression bars. So when we say doubly reinforced beam, meron kang reinforcement sa compression side, meron din sa tension side. So top and bottom na. So sa mga hindi pa nakapag-subscribe, so don't forget to subscribe and hit the notification bell. So let's start our lecture now. So this is the typical cross-section ng isang doubly reinforced concrete beam. So, ito yung width ng beam, ito yung effective depth. So, this one, ito yung AS1. So, AS1, siya yung area nung steel sa tension side ng reinforcement natin. So, pwedeng AS1 or AS. Okay. So, ito naman yung reinforcing steel sa compression side. So, let's call this AS prime. So, ito gawin natin AS. Now, ito yung C. So, ito yung depth ng compression block. So, ito naman, yung effective depth naman from top of the beam hanggang dito sa centroid ng compression to reinforcement bars. Ito yung tinatawag natin na D prime. So ito yung dagdag natin yung D prime. So, ito yung depth of compression block. Ito yung A. So, ito yung strain diagram niya. So, the maximum strain for the concrete block is 0.003. Ito yung strain naman ng compression bars. Ito yung depth of the neutral axis. So, this is D minus C. And this is the strain naman ng tension bars. So, ito. Pwede natin AS yan for simplicity. So, ito yung diagram niya ng couple diagram. So, hinati natin sa dalawa. So, this distance, ito yung D minus A over 2. Ito yung moment arm niya. While this one, this distance is D minus D prime. So, ito naman yung moment arm niya. So, ito, C1 is the compression created by the concrete. So, yung C1 mo, so this is equal to 0.85 FC prime AB. While yung C2, so ito yung compression naman induced by this, the compression steel. So, this is AS prime FS, or it could be FY. So, i-prove pa natin mamaya. Now, ito, T1 is equal to AS1 FY, while T2 is equal to AS2 FY. So, AS1, so yung T equals T1 plus T2. So, kumuha lang tayo dito tsaka dito para may pang-couple dito sa compression steel. So, therefore, AS equals AS1 plus AS2. So, now, paano ba natin malalaman kung kailangan ba ng isang beam yung compression bars? So, ito lang yung kailangan i-satisfy na condition. So, yung raw or the steel ratio, if it is greater than raw maximum, therefore, compression bars are needed. So, kung maalala natin dun sa previous lectures natin, distinctly reinforce, when raw is greater than raw max, so that is compression controlled. So, ibig sabihin, hindi mag-yield yung steel. So, ang mag-yield yung concrete. So, kapag yung concrete yung nag-yield or naunang nag-fail, so, ang tendency is rupture failure. So, to avoid that, maglalagay tayo ng compression steel, ng steel sa taas, para yung steel yung maunang mag-yield before yung concrete sa concrete. That is why we have to design the area of steel sa compression side na kailangan para mag-yield yung compression bars. So, just like singly reinforced concrete beam, so pwede din kasi dito mag-yield yung bar, pwede hindi mag-yield, pwede din balance condition. So, ang goal natin in this lecture video is to have a doubly reinforced beam wherein the compression still yields. So, paano ba natin masasabi if the compression still yields? So, dalawa yung pwede nating i-check. So, any of the two kaya atin tingnan. So, first, if your is raw, so yung raw, yung steel ratio nito nung tension steel minus raw prime. So, raw prime is the steel ratio ng compression steel. So, it must be greater than 0.85 Fc prime beta D prime times 600 over Fy times D times the quantity of 600 minus Fy. So, once masatisfy itong condition na to, compression steel or compression bars yield. So, we also have isa pang ang condition na pwedeng satisfy. So, through the strain diagram. So, if this is C, this is the strain of the compression steel. So, this is C minus D prime. So, if we draw the ratio and proportion between this triangle and this triangle, we have 0.003 to C equals the strain of the compression steel or compression bar is to C minus D prime. The the strain on the compression side is equal to (0.003 times C minus D prime over C. So, alsin natin ito. So, yan yung strain natin sa compression steel. So, when the strain for the compression steel is greater than Fy over the modulus of elasticity of the steel, compression bars yield. But when it is less than, so when the strain of the compression bars is less than Fy over the modulus of elasticity, compression steel does not yield. So, ito lang i-check natin. So, kapag ganito, Fs prime equals Fy. While kapag ganito, Fs prime is not equal to Fy. And your formula for Fs prime is equal to 600 times C minus D prime over C. So, ito lang i-check natin. It's either this one or ito. So, subukan natin sumagot ng sample problem. And sample problem is here. Now, sabi dito sa sample problem, a rectangular beam has a width of 300 mm and an effective depth of 600 mm. So, it is reinforced with 632 mm diameter at the tension side at the bottom. So, ito daw. So, this is 632 mm bars for the tension side. And 225 mm at the compression side at the top. So, ito daw. Dalawang 25 mm. Steel covering is 62.5 mm from the compression side of the beam. So this one, so steel covering, so I mean to say this one, ito yung D prime, so this is 62.5 mm. Now you have FC prime of 34 MPa and Fy is 414.6 MPa. So, number 1, determine the depth of the compression block. So, we are required for A. Number 2, determine the design moment. So, design moment is the ultimate moment, mu. And number 3, determine the uniform load it can support in addition to a dead load of 20 kilonewtons per meter. So, we are looking for the value of the live load. So, let's try to answer this. So, number 1, determine the depth of compression block. So, for number 1, so check muna natin if kailangan ba talaga natin ng compression bars. So, check natin if there's a need. So, kunin natin yung rho. So, rho is equal to A S over B D. So let's check if rho is greater than rho maximum. So rho is AS over BD, so rho is pi over 4 times 32 squared over 300 times 600. So yung rho natin will be equal to, so that is pi over 4 times 32 squared divided by 300 by 600, and that is equal to 6 times 6 kasi 6 yung bars natin, so times 6 natin. Yan. So times 6, that will be 0.0268. Now, i-compare natin siya sa rho maximum. So, rho maximum is equal to 0.75 of rho balance. So, that will be 0.75 multiplied by 0.85 FC prime beta times 600 over Fy times 600 plus Fy. So, since yung FC prime natin is 34 MPa, so let's check for the beta factor based on the NSCP 2015. So, hanapin natin. So, ito yung table. So, values for, so ito yung beta factor, beta 1 dito. Beta 1 for equivalent rectangular concrete stress distribution. So, andito tayo sa range na to. So, we are greater than 28 but less than 55 MPa. So, ito yung formula natin. So, 0.85 minus 0.05 times FC prime minus 28 over 7. So, dun sa naunang code, dun sa lumang code, 30 yan. So, ito yung nabago. So, kunin natin yung beta factor. So, beta is equal to 0.85 minus 0.05 multiplied by FC prime minus 28 over 7. So that will be equal to, solve natin, beta prime is 0.85 minus 0.05 times the quantity of FC prime natin. So this is 34. So times 34 minus 28 over 7. So yung beta factor natin is 0.807. So now, pwede natin ito i-substitute dito. So we have the rho max is 0.75 times the quantity of 0.85 times 34. So that's the FC prime times the beta factor na nasolve natin times 600 divided by Fy is 414.6 times the quantity of 600 plus Fy. So that is rho max equal to 0.75 times 0.85 times 34 times 0.807 times 600 divided by 414.6 times 600 plus Fy of 414.6, and that is equal to 0.0249. So, i-compare natin. So, this is, the rho is greater than rho max of 0.0249. So, therefore, compression bars are needed. So, now, check naman natin kung mag-yield ba yung compression bar. So, we have the formula rho minus rho prime is equal to 0.85 FC prime beta D prime times 600 over FYD times 600 minus Fy. So, meron na tayong rho kanina. So, yung rho natin is ito 0.0268. Nakuha natin yung rho prime. So, yung rho prime is equal to AS prime over BD. And that is equal to pi over 4 times 25 squared. So, the size of the bar times 2 kasi dalawang bar siya over B times D. And that is equal to so we have pi over 4 times 25 squared times 2 over B times D. So that is equal to 0.00545. Now, subtract natin yung rho minus rho prime. So, rho minus rho prime is equal to 0.0268 minus 0.00545, and that is equal to minus 0.00545. So we have 0.02135. Now, ito naman yung solve natin. So, that is equal to, so ito, It must be greater than pala. Ayan. So, this must be equal to 0.85 times 34 times yung beta kanina na nasolve natin times d prime of 62.5. So, ito yan. Times 600 over Fy times d times 600 minus Fy. So, that is 414.6. So, that is equal to 0.85 times 34 times 0.807 times 62.5 times 600 over 414.6 times 600 times quantity of 600 minus Fy, and that is equal to 0.0 189. So if we compare this one tsaka ito, so 0.02135 is greater than 0.01896. Therefore, compression still yields. So, after natin ma-check kung nag-yield ba si compression steel, so we equate natin to, yung C is equal to T in order to solve for the value of A. So C is equal to T, and your C is C1 plus C2 equals T1 plus T2. So, ito yan. Now, C1 is 0.85 FC prime AB plus yung C2, ito is AS prime. So, since compression yields, Fs prime equals Fy. So, as AS prime Fy equals T1 plus T2 is equal to T. So, this is AS Fy. So, by substitution, we have 0.85 times 34 times A times B of 300 plus AS prime. So, ano ba yung AS prime natin? So, AS prime is pi over 4 times 25 squared times 2 multiplied by Fi of 414.6 equals, so AS is pi over 4 times 32 squared times 6 multiplied by 414.6. So from here, makukuha natin yung value ng A. So your A will be equal to, so para natin solve. So we have pi over 4 times 32 squared times 6 times 414.6 minus pi over 4 times, so we have times 25 squared times 2 times 414.6 over 0.85 times 34 times 300. So yung value ng A is equal to 183.81 mm. So that's the value of A. So nasagot na natin yung number 1. So A is 183.81 mm. So next, letter B, determine the design moment mu. So now, since mu yung pinapahanap, so we can use either ito, yung sa compression side or sa tension side. So for letter B, we have mu is equal to C1 times D minus A over 2 plus C2 times D minus D prime. So, saan galing yan? So, galing yan dito. So, we have C1 times, the moment term is D minus A over 2 plus C2 times D minus D prime. So, pwede na itong gamitin natin, T1 and T2. Pero ito na, dito na lang tayo kasi naisulat na. So, we have okay, nakalimutan nga pala natin dito yung reduction factor na phi. So, paano natin malaman yung reduction factor natin? So, tignan natin sa NSCP. So, ito. So, let's see kung tension controlled ba ito. So, let's solve for the tensile strain of the tension steel. So, kapag greater than 0.005, ito yung gagamitin natin, 0.9 na strength reduction factor. So, from here, so galing dito, we have to make ratio and proportion. So, kuha natin yung C saka yung 600 minus C. So, yung ating A is equal to beta times C. So, yung A natin na solve ito. So, we have 183.81 equals beta factor natin kanina ito is equal to 0.807C. Therefore, C equals, so we have 1 83.81 over 0.807. So we have 227.77. So ito 227.77. Well, this one 600 minus yung kanina. So this is 372.23. Okay, so by ratio and proportion, we have 0.003 is to 227.77 equals the steel strain is to 600 minus C, which is 372.23. So the strain of the steel or strain of tension steel is equal to, so we have 0.003 times 372.23 over 227.77, and that is equal to 0.0049. So that is 0.0049, and that is less than 0.005. So since this is lesser than 0.005, so saan ba siya papasok? Yan. So ito yung gagamitin natin na strength reduction factor. Nasa transition siya. So the strength reduction factor is equal to, so we have here phi equals ito, .65 plus 0.25 multiplied by strain of the steel minus, so ito yung maximum na strain ng steel under compression over 0.005 minus, so strain of steel under compression. So that is the formula. So now, sabi dito sa NSCP, so the strain reinforcement for compression controlled shall be Fy over the modulus of elasticity of steel. So eto, solve natin to. So the strain for the compression controlled is Fy over modulus of elasticity of 200,000, and that is equal to so we have 414.6 over 200,000. So that is 0.002. So now, masolve natin yung strength reduction factor phi. So phi is equal to 0.65 plus 0.25 times yung nakuha nating strain ng steel kanina, 0.0049 minus 0.002 over 0.005 minus 0.002. So your strength reduction factor is equal to 0.65 plus 0.25 times 0.0049 minus 0.002 over 0.005 minus 0.002, and that is equal to 0.89. So 0.892. So yan yung strength reduction factor. So therefore mu is equal to 0.892 multiplied by C1. So C1 natin is 0.85 times F prime C times yung A natin nakuha kanina is equal to 183.81 multiplied by B times D minus A over 2. So yung A is 183.81 over 2 plus C2 is AS prime. So AS prime is pi over 4 times 25 squared times 2 times D is 600 minus D prime 62.5. Divide natin sa 1,000 squared to get value of mu of in terms of kilonewton meter. So ang 0.892 multiplied by the quantity of 0.85 times 34 times 183.81 times 300 times 600 minus 183.81 over 2 plus AS prime times FY. So nandito yung FY. So 414.6 times D minus D prime times 1 over 1,000. Hindi na kaya. So that is divided by 1,000 squared. So your ultimate moment is 917.42 kilonewton meter. So, kasagot na natin yung design moment. So number 3, determine the live load can support in addition to a dead load of 20 kilonewton per meter. So number 3, so we have the ultimate moment mu is equal to W L squared over 8. So kunin natin yung W tsaka yung L natin. Ano ba yung L? So do we have a given L here? So wala pala tayong given L dito. So hindi natin to masasolve. So dagdagan na natin. So let's see if L equals 6 meters. Yan, para masolve natin. So from here, W equals 1.2 dl plus 1.6 ll. So substitute. So mu is 917.42 equals W is 1.2 times dead load of 20 plus 1.6 live load multiplied by L squared of 6 squared over 8. So your uniform live load is equal to, so shift off na lang tayo, 917.42 equals 1.2 times 20 plus 1.6 times the live load multiplied by L squared over 8. So shift solve. So what is the live load? So our live load is 112.42 kilonewton per meter. So check na ulit natin. 97 point. So 917.42 equals, so 1.2 times 20 plus 1.6 times x over 8 times L squared. Okay, so ito nga. So we already have the answer for question number 3. So nasagutan na natin. So thanks for watching, guys. So abangan nyo ulit yung susunod natin na video. So next natin na lecture is compression steel does not yield.